We will start with this lesson called Advantages of a Declarative Configuration. So now why we need this, I mean, why we need Kubernetes, and this is a little important actually. So that is the reason we should talk about this. Like, so basically in Kubernetes we have all, basically the first advantage is like it is less error prone. So basically when I say it is less error prone Kubernetes, because I mean, as a human being, we don't have to worry about. I mean, we are only worried about the desired end state. So basically, imagine if you are using a traditional programming, like a traditional imperative style, wherein you have to fire like you want to install an application, and now and for that you need to fire like around 50 commands for you have to SSH to a machine, and then you have to fire write some commands. And if suppose at a very instance your 49 command got failed, okay, so it causes problem. So and companies like Google or any, they don't use SSH or any traditional imperative type of cluster match. So whenever you want to do any cluster management, so they want or similar technologies, but they need they need something. What they're looking for is basically something they want to define that state what the application should be, and that's it. I mean, they don't want to run all these commands and what we used to do in traditional way. So and so basically in Kubernetes everything is given a unique name. Okay, so you talk about pods, you get talk about namespace, so everything is given a unique name. So basically, if you just, I mean, if you when we say idempotent, so basically you can call that pod multiple times, okay, and without changing the state of an object. So that is the meaning of idempotent. So I mean, so the key takeaway from here is basically Kubernetes. In Kubernetes, we have every all objects given as a unique name. Okay, so that's the way I mean, so by using it, I mean, with this name, Kubernetes understands. Okay, it. I mean, Kubernetes is smart enough to understand what is the further corrective actions which needs to be taken. If suppose the pod goes down, so it will restart the pod automatically. So we don't have to wait for it. And so suppose continuing with this advantage, like suppose you are having an application uh, and you want to do an upgrade, you want to tell the you want to upgrade the application or website or your or your service. So basically you need to you need to declare that state in the Kubernetes in the YAML file, and Kubernetes will find out all the detailed steps which needs to be done as a part of upgrade. And suppose you want to do a rollback, so you have to just decide, you have to just move it, you have to just bring on the previous YAML file, like the previous uh, state of the system. So with that, Kubernetes will do it automatically. You don't have to do it on your own. So I mean, because if you in an imperative style, what we need to do, we need to write all the reverse instructions, uh, which is like little, which is of course complicated as well as error prone. Like human errors are always possible when we type these commands. So most of the times, if you see any website, it is if it is says it is down for maintenance or something like that, so that means they are using the imperative approach and not the Kubernetes approach. So most of the times I mean, we see like if the website is down for maintenance, some banking site we see, so that means they are still using the imperative approach, and they haven't yet moved to Kubernetes. So this is one thing. I mean, this is one thing which we should note about declarative configuration. Now we should talk about little about you have any questions till now, or you're good? Okay, okay. Yeah. So we should talk about something in history about Kubernetes. In Kubernetes is like if you see here in my previous slides, I am using K8 everywhere, right? So so Kubernetes, yeah, Kubernetes is also called is referred to as Kubernetes. So basically, there is a K and Kubernetes. So that Kubernetes is like a eight string word, which is of eight length, and basically what it I mean the, that eight symbols that Kubernetes. Okay, so that is the reason it is called K8. So usually you will find in your companies like people are just referring to eight letter Ubernet. It is called Ubernet. So and it has a meaning actually. It has a meaning like if you see the symbol, it looks like a helm of the ship. Like basically that logo. It says like yeah. It means like a captain of the ship and like and and this logo yeah this logo means the wheel of the ship and it has been announced it was done by started by Google in 2014 and it was basically it started with it it was influenced by basically a Google's internal containerization architecture called Borg and Borg was an internal container system which was used by Google prior to Kubernetes. Now they have switched to Kubernetes but if you see like many contributors like the names here, Joe Beda, Brendan Burns, McLuckie, they are all like they are all like key contributors in Kubernetes, and they are all from Google basically. And Ku- Google initially started with this name called Project Seven. So if you see here, like there are seven prongs of this sheep, one, two, three, four, five, six, seven. So basically, that is the reason it is called like Project 7 as well. So it was originally called Project 7 as well, and it started in 2015. And after that, Kubernetes started with they partnered with Linux platform, and they formed something called as Cloud Native Computing Foundation. So I mean, just a few points to note here. And now, the benefit of Kubernetes is it's a very popular interview question actually. So, like what it does. So basically, it avoids like, of course, it avoids manual intervention. So imagine a DevOps scenario. So, for example, someone is on-call support, and the team has deployed an application, and suppose that instance of that app goes down, and that too in the middle night, say a container and of course, the L1 team notifies that engine DevOps engineer that okay, that system is down and you need to investigate the issue. And basically, if you do it manually, so to manually you need to spin up one new Docker container instance, and then you have to get a new IP, then update the DNS records, and then set up the networking and service discovery, and then eventually run all your tests to make sure that the application is up and running fine. Actually, this is really very time consuming. I mean, and it's also very inconvenient to do at night. But what Kubernetes can help it, like it can actually handle gracefully all these steps. And basically, you have defined basically as a DevOps engineer, you have defined a state. So Kubernetes will keep on iterating that loop. It will keep on iterating the loop, and it will make sure that the application is meeting the desired state. So as we discussed before, like we don't have to log into, we don't have to SSH any box or anything. Kubernetes will take care of all those, I mean, all those stuff. So because we discussed in our previous, so basically that is the reason Kubernetes is also called as self-healing system because it reduces the burden of a DevOps engineer and it also increases the overall like application time. So That is the reason it is also known as a self-healing system. So you are saying something? You had some question? Okay. Hmm. Yes. So if it is a yeah, if yes. So if it is a memory issue, then so basically you can in YAML file you can define the replica. So you can define like the number of replica of your application, and you can also specify. So basically whenever the application is scale up, so that memory will also go up. Okay. And so basically you have defined it in the YAML file that okay, I need if any down if for any if suppose if the I mean you want at a particular instance of time you want tell 10 instances of your application to be up and running, and you specified like 2 gigs of memory always. But if the load increases, so you have written in your YAML file that okay that you the scaling which should happen, that there is something called as a replica factor replica. So there is something called as a replica keyword into the YAML file. So it will automatically scale up, and you don't have to provide. Yeah, you don't have to scale up the memory. So Kubernetes master will take care of it. So that is the reason the manual intervention is removed when you use Kubernetes. So are you getting me? What? Yeah, yeah. The yes, yeah, 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 yeah. So yeah. Now one this is a very important thing like Kubernetes enables application portability across different cloud environments. Now what happens is like when we work on a particular company, so some team is working on Azure APIs, some team is working on AWS APIs, some team is working on Google platform, GCP platform. Like these are the major platform provide like cloud providers. Now it becomes really very yeah, it becomes I mean you can develop your application by directly with these APIs directly. You can directly port your application and deploy it to Azure environment. But if you do that, then if someone does, if some suppose team A is using AWS APIs, team B is using Azure APIs. So when they suppose and they if they want to talk to each other, like if they want their APIs to talk to each other, then it becomes a little problematic to have a basically interoperability issues like I mean sometimes of course these APIs do handshake each other very well, but sometimes there are bound to be some issues. But if you write your application and I mean basically it becomes hard to port your applications from I'm suppose because of cost issues the company decided to move from Azure to AWS or AWS to Azure or AWS to GCP. So then it becomes really pain in the back to move these applications to a different cloud. So if you are using Kubernetes, so this problem is solved. How? Basically, you write your code, you develop your code, and yeah, you develop your features, and basically instead of going to a particular instead of going to a particular cloud provider, you are deploying it on the Kubernetes APIs. So when you deploy it to the Kubernetes APIs, it enables automatically the application to have a portability between different cloud providers. So basically, how you can do that is basically you build your application and you deploy it to Kubernetes APIs, and then you can port your apps to any cloud. Like Kubernetes cluster will work with any cloud. Like you don't have to worry about uh, uh, which cloud to work on. Yeah. So all you need to do is spin up a new cluster in your cloud provider and declare the and provide the declarative configuration for your app. That's it. I mean, as an application developer, the work is done. No more no more hanging around for like, yeah. So the interoperability between different cloud environments is the key when you're using Kubernetes. So yeah, I mean, this was one of the point. Yeah, we discussed this so basically this is the pictorial view of basically this is your app, and this is you have built your app using Kubernetes, this wheel structure, and then you can deploy it. I mean, once you have deployed it, you have deployed it into your API into Kubernetes, then your company either it works on OpenStack, GCP, Azure. I mean, you don't no need to worry because Kubernetes has these platforms, has these plugins. This cluster has these plugins, which can easily integrate with all these different cloud environments. So, basically, I mean, if you want to create a load balancer on AWS or persistent volumes on AWS or in Azure, so Kubernetes knows about all those stuff already. So they have plugins for that. So that was one thing. And so yeah, so basically in a nutshell, Kubernetes does an easy application rollout, scaling and rollbacks. Uh, so basically Kubernetes it does an API abstraction. So if you look into this point, like grouping of container images into one deployment, how so imagine a scenario in an example like in a particular company there are a lot of teams like it's called that the ideal example is like a team A, team B, and team C. They are so competent with their APIs that they build their own APIs and they deploy it into a container image. Now this all team A, team B, and team C, they all have their own images. Now it has to be abstracted into a particular deployment. Uh, I mean, they are not like they cannot work in silos. They have to be. I mean, due to Scrum. I mean, in their Scrum meetings or in their sprints, they have to talk to each other so that the eventual application is being built. It's not like a monolith. I mean, nowadays we are not building a monolith app. Like it's like when we like it's not like a big giant Java application and we are deploying it all together. Nowadays it's all about isolation and microservices, right? So basically, one team develops one microservice, another team develops another service, another team develops another service like that, and then they all bundle up together and like basically they group all these containers and they put into one deployment. So Kubernetes provides these abstractions. So it's suppose I will show up in the next slide scaling a service upward. Like as I discussed before, uh, suppose so suppose there are three different microservices, and one microservice needs a load balancer because suppose a call center application, for example, a call center application. Now, this call center application, no one can ascertain how many calls can be reached to a particular service in a particular day. So, based on the calls, that 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 particular microservice has to scale up. Okay, I mean, and once the traffic is reduced, it has reduced to normal, then we that service should roll down to its initial stage, because we cannot always have a 10 instances of microservice up and running, because it's costly and that is not efficient. So basically, you want to scale up your microservice upward, and then once the load is reduced, then you want to roll back. You want your service to roll back. So I mean, so basically, Kubernetes groups all these container images by different teams into one deployable unit. So this is another important feature. Basically, deploy it manages the deployment. It manages the deployment of multiple teams. So I mean, it also enables like how microservices can interact with each other. So I mean, we have already discussed like scaling a Kubernetes cluster is easy because we can define the replica factor and and you can create a new worker node and then you can join it with the cluster. I mean, you don't have to do it manually because your job is done. You have to define the declarative state of your application, and the worker node addition will be taken care of by the Kubernetes master. So uh, we do not have to worry about it. And also the rollbacks, it will just do it. The Kubernetes will take care of that. And as per the configuration file, basically the YAML file. So this is one thing. And microservices. So basically, if you see, yeah, tell me. Yes. So the use of worker node is so basically imagine you in your cluster like you have 10 nodes up and running or like 10 nodes will be very costly for usually like 5 nodes up and running for your application and one is master and like five is worker nodes. Now you have defined in your config file, which is basically your YAML file, that you have defined that okay, once the load reaches to a particular threshold, okay, then these nodes should scale up to 10, okay, from 5 worker nodes to 10 worker nodes. So basically you are you want I mean, as we discussed before, like at the middle night, suppose you as a DevOps engineer, you are working in a west coast west Pacific like a west coast area. Now in the east coast, all of a sudden in the night, the traffic goes up and you don't know about it. So the Kubernetes will automatically add those worker nodes, basically the scaling up of worker nodes based on your YAML file or the config file, and also roll down as the network goes, as the load goes down. So the addition of a new worker node, you don't have to worry. You define your application state, that what is your desired state. Okay, this is the CPU memory you want, this much amount of this much amount of memory, like 2 gigs of memory you have provided in your YAML file, and this much amount of replica. Basically you want these many number of instances of your application to scale up when the load when the load reaches a particular threshold. So you define all this stuff into the config file, into the YAML file. So Kubernetes will take care of all those, adding the new worker node and then removing the worker node. Kubernetes will take care of on your AWS architecture or on your GCP or Azure, wherever. So we don't have to worry about that part. So that is, yeah, that is the meaning of yes. So yeah, remember we discussed about master slave architecture in the previous session. Like Kubernetes has a one master, and like all these slave machines are like worker nodes in Kubernetes world. These are called as worker nodes. I mean, yeah, in a cluster, these are the work. Yeah, so these slave machines are worker nodes actually. Okay. Yeah. So, this is like a typical one example of a service microservices. So basically, in this example, like we have, if you see here, there are well, this on the left hand side, these are all the customer care functionality, and this is basically a typical retail shop. e-commerce application, and in the middle there is an orders, like the orders block. So, and in the end there is a shipping block, and there is an inventory block, and there is a finances block. So all these and these are talking to each other with a message broker, this block, and this is the user API. So basically the user portal. So basically in the microservice architecture, these are all loosely coupled services. So basically they are not dependent on each other. Suppose team customer care team has developed these APIs, like self-registration API, profile API, re-registration API. So these are all like independent services, and there is another team who is working on orders services. So they build these all these APIs: my shopping API, order fulfillment API, customer API, orders API. Now there is a third team, shipping team, who developed all these order tracking APIs. So they are all independent teams. It's not like a giant monolith application. It's like which are tightly coupled. Like all these APIs are independently working on each other. So basically, what they do, they develop their application and they expose their RESTful API, but they deploy it to they deploy it to the Kubernetes, and then they expose the RESTful API. So when we do it RESTful, when they expose it as a RESTful API, then it enables the other services like customer care exposed one RESTful API. Then the orders will consume those APIs. Okay, and so basically, these are all working as an independently deployable application. Like all these are containers. So all these are Docker containers, and and all these are deployed to Kubernetes. Yeah, tell me, Vivek, you're saying something. What is the difference? Yeah. Yes. So yes. So in the early days, what suppose there is a bug comes, a production issue comes. So the developer has to, or the whoever the working on the issue has to download the entire application into his machine. Okay, from Git or from wherever, like Jenkins or whatever. Now to debug it, he has to download the entire application, and then he has to do a debugging of that. Now imagine for in this scenario, in this loosely coupled scenario, this is the entire block. This is the entire block in the entire application. Okay, with previously all these have to deployable, like customer, like self registration API, my shopping API, order tracking API, finances API. You don't need to download it, but still you have to download because this is like a giant application. But with these microservices, one needs to only download from Git, just get this self-registration API. Suppose the issue comes that okay, uh, there's an issue happening at the air self-registration while the customer is not able to register the call. So so the engineer doesn't have to download the entire application. All he needs to do is just download this self-registration API or my profile API and re-registration API, and then he or she can just debug that particular API. Okay, what is happening here? So uh, because I mean, because it has been deployed to Kubernetes, like it is basically, it is a containerized application, and it is an independently deployable application. So one need not to deploy the entire giant application. He or she has to just, so this is called like loosely coupling. So each of these boxes are like independent services. So suppose there is an issue at the, maybe at the end of like order tracking API, like the, suppose the so customer is putting the credit card details, and the order number is not getting generated, for example. Okay, now for to debug that, one need not to download all these customer care APIs and order APIs, everything. What he can do is he or she can just get this order tracking API, and then he can debug. because it is a independently deploy. I mean, it is an independent thing, so he doesn't have to download that entire thing. So that is the beauty of microservice. So yeah, so and Kubernetes uses pod abstraction layer to manage all these microservices. We will talk all these things later, but as of now, just get this picture of services like microservices. So Kubernetes is all REST APIs and microservices. So that is the reason this needs to be understood well. Okay, and yeah, so I mean, customer can raise from his phone, from browser, or from Apple Watch or whatever. But if any issue report gets reported, so but all these are like independently working services. They are not. Uh, I mean, they are all. I mean, they are all independent. All right. Okay. Now what we have in next? Yeah. So basically, the ideal size of a development team, it's called like two pizza boxes. An ideal team should be like a six people. Okay. Now, so basically, one service is developed by one team, and now it is being consumed by another team, team B. So now you have something called as container registry, and each service has like multiple Docker images, which is pushed to a container registry. So question might come like why I should break all these large application which we discussed here in the before so why we should decouple all these things. What is the advantage like so the big advantage is like each service is an independently deployable Docker image. So basically, suppose there is a release which is going to happen for the application, so one need not to wait. Okay, shipping team has done their work. They can go ahead and deploy their application to the production, and customer care has done their work ahead, and they can go ahead and deploy. So they are not waiting. They are not independent. They are not waiting for each other. Okay, so because they have all like independently deployable image. Because what they have done is they have developed their Docker images application. So basically these images contains the app, and now you have pushed your Docker image to a container registry. So and your work is done. So basically, but as we discussed just now, like for a monolithic application, so we need that entire application to be downloaded or deployed. Suppose there is a production release which is going to happen, so that entire application has to be deployed to production rather than one APIs. Like if we are using Kubernetes, we can just deploy one service. I mean, whichever team has finished their work, they can go ahead and deploy. They need not to wait for the other team to finish their work and then deploy. So this is like a one of the thing to needs to be understood well. And now one more one more point here is like suppose a registration API. Now uh, uh, this registration API on a Black Friday, for example, you might get a lot of like humongous amount of traffic. Okay, so so in that case, suppose you want to put a load balancer just for this into the registration API, and basically you want to create several replicas of that registration APIs, and suppose without reconfiguring the entire application. So basically, Kubernetes will does that automatically. I mean, this is called as API abstraction. Like basically, all these terms will come up like pod, deployment, load balancing, naming, service discovery, namespaces, and so on. So all these are all these are API abstraction techniques. So if you with this, suppose in the production you think ahead. Okay, uh, see, there are two ways. Either you deploy your application and then you see the traffic coming in, and then you put and then put apply the load balancer here. Okay, depending on the traffic. And the other way is to think ahead. Okay, and if someone thinks, okay, registration API will have lot of traffic, and order fulfillment API will also have a lot of traffic. Okay, so let's put a load balancer into the registration API and into the order fulfillment API. So you define all this as a part of your deployment. So this is as a it's pointed here like API abstraction. So load balancing you deploy. So you do you just define it into the YAML file. So that's it. I mean the the task is done for the load balancing stuff. So I mean yeah. So that we will discuss it more like what is the pod, what is the deployment. We will see in maybe next lecture. And so I think that's like an end of this session thing. Like this is like a summary uh, why we should think why we should know about microservices in Kubernetes. It's an architecture of building an application. We saw like how independent teams can build their application, how they can deploy their Docker image and put it into the container registry, and then they can independently put it to production. So if someone is using Kubernetes, of course. And we also saw like how application is like a loosely coupled service, not like a tightly coupled. So it's not like a giant monolithic application. We saw it like a and we also saw like this might not be an ideal case scenario, but it's being said like two pizza boxes a team to be it's like an ideal team. And we discussed this as well, like each service is containerized. Basically you create a Docker container and then you push it to a Kubernetes registry, and it is independently deployable. And all the services are decoupled. So if you and they are all well defined APIs and with their own load balancers. And I mean like bug fixing is like a it becomes easier when we use these Kubernetes APIs abstractions. And also like load balancing is the key. So I think yeah, that's pretty much it. Yeah, so if you have any questions, if you have patience, we can talk about it. Yeah, okay. Yeah. So yeah, so this is, I mean, these are quite important things like multi-cloud and this DevOps scenario and history. No one will know. I mean, I just gave it for your interest, like why it is called Kubernetes, why it is created, and upgrades and rollbacks. I mean, these should be kept in mind because we start the programming. I mean, before starting the programming, we should know why we are doing all this stuff. So um, to look at the bigger picture, and this is that is important actually. Okay, Vivek. So I think